little bit here. Got a meeting that should have happened, but I guess it's gotten postponed a bit, so I don't know how long I'm going to be live for right now, but I figured we'd at least see if we can get a short stream in for a bit of work. Hang on, let me make sure this thing's working, and then I'll talk about what I want to do. Yeah, this works. Cool. So I want to do something kind of similar to phasic policy gradients. I have maybe 50% confidence at best that this is going to actually be useful, but we're kind of at a spot where it would be relatively easy to add. So I sort of just want to do it and see. That better not be. Yeah, okay, we're good. Try something like this. Oops. A little scattered today. Yesterday was like just cranking on work, and I'm a little scattered today. I had to catch up on meetings and stuff. All right. So we get PPG epochs here. And then the only thing that we have to really add to this to make this work is this like extra phase after training. You know, technically I think that I can just do, if I just want to test something quick, right? And probably just copy paste a lot of this. It's a little awkward. It is a little awkward. I guess we do just literally paste. For now, we just repaste this. And we'll just like delete stuff. So all the freaking code. We'll like remove all the sections we don't need at least. And then we'll come up with a cleaner way to do it if well, we'll come up with a cleaner way to do it if it works. This. Just do a little minimal version of it. Does need this. Doesn't really need this. And we don't really use KL target. There's a third person I've had asking me about hierarchical RL this week. I guess we will have to do something in that area. I think we're just going to do the simple thing, though, like fast, slow LSTM. That I actually think will work. That should just be like free win. Implementation's a little tricky. I have to think about it. Right, so the only thing that's really different with the iterations here, right? Is you do this like KL loss. And of course, I get the right as soon as I start streaming, I get meeting call. Okay. Um, Let me see. I think I'm gonna have to just go take this, and this will be just like a quick 10-minute thing, and then I'll come back and get to this. Let me make sure. Okay, no, they're at lunch now, so we will keep streaming. Cool. Perfect. So we will get to finish this. This is kind of it, isn't it? Oh yeah, the one thing that we forgot here, the annoying bit, right? So you have to do you actually like need to do this thing again. Maybe just this block. You have to like recompute logics on everything in the data set. I think how we would do that. Oh, actually, this is kind of easy, isn't it? Yeah, this is kind of easy. At least to do this as a hack is kind of easy. We just need to go through the full data set here. I wrote it in a way where it's a little awkward to do that, but I can just do something like this. Yeah, something like this. And then what we do is experience dot log probs of index. It's set to new log probs. I think that's the only thing we need, right? The heck? Hang on. I assume that's just a battery test. That's weird. Unless somebody's trying to get my attention. No? Just a battery test, I guess. Alright, so, I think this is just it. Forgot state. 1 sec. Forgot state. Oh, hang on. I think I screwed something up here. Yeah, I totally screwed this up. this can be n samples, and this is data.experience. We don't even need this. Deal with one message. Okay. Okay, this is still totally screwed, right? Pretty much all I'm trying to do here is I'm just trying to hack this super quick so that we can do regular PPO epoch, eval the entire data set or the entire batch so that we can update the log probs and then run additional value function training. That's all I'm trying to do. Yeah, okay, so this seems like this is fine. Why is log props like that? Wait, why is... Oh, shoot. You need log, it's not log prop, right? So what you need is... It's something like this, experience rows, and then like that. See if this runs. It doesn't matter if this is a hack, I just need to like have something that I can test this with for now. And then I like, if this is actually good, then I will think about how I can do this without being a ton of code. Okay, so that actually runs. We need to now, so this needs to get normed. Where's the KL here? Yeah, okay, so this can't be batch.logprobs. So ppg logprobs equals all logits idx. And then this has got to be, this is not new logprob. This is logits. Logits. Something like this, I think. We'll see how this does. It's probably better to have, first of all, catch, and then I actually don't know how this is going to work batch. We'll see. Okay. Is this obviously wrong or no? Seems pretty wrong, right? Okay, so that doesn't work, right? Okay, so this doesn't make sense because like somehow we've somehow like broken this. We didn't mess up the scheduler. We just comment this whole block, it should work, right? Yeah, so if you just comment this block out, it works. So we're clearly just breaking something because this shouldn't even be optimizing anything with the losses zeroed. So like some variables getting updated that shouldn't be. Where's this lined up? That's lined up correctly. Welcome, YouTube folks. So what this is here, I am currently attempting to do some weird hodgepodge of phasic policy gradients. This thing separates policy learning from value learning. It's kind of slow though. So I was coming up with a version of this that lets you just do PPO for one epoch, because they say that you don't really benefit beyond one epoch except for training the value function, and that let you do more epochs on the value function using the PPG style loss. So that's what I'm currently trying. I have no idea if this works. I do know that the current version, it should work better than this, so I'm somehow breaking it here. So goal here is just to see if we get anything out of this. This is kind of like invest a few hours, see if anything works kind of a gig. If it did work, best case result would be that this lets us get more sample efficient learning when we want it, and then have exactly the same behavior in perf as PPO when we don't want to crank up compute. Let me see what variables would be getting overwritten in place. Maybe this. And this should get zeroed anyways, though. It should be getting zeroed anyways, yeah. I don't know why we do this. This should be up top. What Linux do you use? Just Ubuntu. We tried running Debian on the servers. Was more of a pain in the ass than Ubuntu. I ran like a crazy custom Arch setup during my cringe undergrad years. Now we just Ubuntu. It honestly really doesn't matter that much because like all the dev is containerized anyways. Like this, I'm editing this locally on this machine, but inside of a container that's identical to the container that'll run on our servers. So like host OS doesn't really matter that much except for it being a pain in the ass to get drivers correct on some of them. Okay, let me just sanity a thing. Because like, yeah, let me just sanity a thing. Okay, this does work, right? So what the heck is... There shouldn't even be a loss here. It's 0, right? Oh, Nan. That'll do it. Why is lost Nan? Does KL explode if the distributions are identical? Shouldn't, right? Hang on. What app or program are you doing? I'm here, new here. So this is, I work on reinforcement learning dev full time. It's all at puffer.ai. We do like really high performance games and other types of simulators. And we train agents from scratch on them, and we work on all the tech behind that. So this is like superhuman agent running, playing Enduro. We have like simple games like this and like Breakout and stuff. And then we have more complicated stuff like this miniature MMO, which is really big. So Stream is a mix of doing math on the various different algorithms that go into this, low-level engineering, all the M's are in C, we have some CUDA extensions, stuff like that, and yeah, just generally all the stuff that goes into making RL work. Oh, hang on, can you not do this? I might just be using this loss incorrectly, right? Does this expect the output of a model? What are you supposed to call this thing with? Log softmax, I see. So you're supposed to call log softmax followed by KL. Why is the input log softmax and the target is softmax? Log target, okay. So yeah, I just messed up the usage of this. So the whole thing is crashing because I get nan losses. And isn't it? Hang on, it's input comma target. Yeah, that's correct. Log is true. Let's see what this does. Cannot access. Okay, so now we actually get something. Shouldn't these be the same? Hang on, something's wrong here because I'm pretty sure these should be the same. Wait, this is batch.index. Zero. Perfect. Now this should no longer break everything if I just run this. And what are we getting spammed on here? Nothing. Okay, so this is still somehow exploding. Maybe we're just screwing over the optimizer somehow. It is technically shared. What happens if we actually run with this? Okay, now it actually runs reasonably, so we were just screwing over the optimizer somehow. You get the graphs for this going. I'm going to use the restroom. I'll be right back. And whoops, get token first. And then we will actually start running some experiments on this and see if we can ever get this to outperform the current PPO implementation. Hang on, let me grab the graphs for this. Oh yeah, also we've got Soda on Neural MMO so far with it's just like barely better, but it is better with the new advantage filtering. All right, new graphs go here. Back in a minute. Let me pull Slack channel over to there if I don't show that. This over here. And yeah, we're good to go for dev. So this doesn't do much worse, but it does do worse. Right? Making sure I didn't screw anything up here because I was messing around with some weird stuff. Okay. Then the next question would be, if we do this less often. There's also supposed to be a coefficient on the cloning loss. Hang on. They have a coefficient here. Where's the cloning loss? B clone. Let me make sure that it's not like a super low hyper. They should have a table somewhere. 1. Okay. They want to do this every 6 on average, so every so often they do 6 epochs. 16. Mini batches per aux epoch. I mean, I think one thing we can do is just take this entire block and we only do this 15% of the time or whatever. That's like close to what they're doing. The goal here is that you should just be able to, like, once in a while, make sure that you're training the value function enough. Can you please open Dairy Web? I have no idea what that is. Oh, holy, that actually does something. Wait, that's actually... It's better at least for a little bit. This is not going to be the best M to test on. We could probably test this on, like, something a bit harder. I mean, that's still pretty decent. Can you please open Dark Web? No. Wrong stream, buddy. This is reinforcement learning, Dev. Welcome. You just... Let me see if I match a little bit closer to their hypers, if anything amazing happens all of a sudden. Where's the algo? So do this n pi times. So there's n pi and then e aux is what I need to check, right? 32. And then this is 6. So, okay, that's actually pretty different. So we set this to 6, right? Is there is a data.epoch, right? Hey Ryan. We can just do if data.epoch %32 and do this, right? That's pretty close to PPG. Yeah, Ryan, I'm just trying to see if this does anything real quick. It's like a total mess to implement this thing. But I just want to see real quick if this does, like if there's signs of life here. Is that good? The way I have this implemented, by the way, it would be very, very little perf overhead. I mean, does that just match? Did you add in the awk stuff? Yeah. I gotta test this now on something like a little harder. I don't think what M's I want to use. I could do grid. Grid kind of has a lot of variability, but would grid be an env where you would think the value loss would get stale? Maybe. Let me see if I can do it on grid. Okay, apparently it doesn't like that. We have a whole bunch of stuff to fix with some of the env bindings and the latest. Yeah, totally screwed it here. We have some stuff to fix with the latest env bindings. All right. Okay, I don't know. Maybe I tested on Snake or something real quick. I think that one works. Need to add in the aux head. Not a big deal. Okay, let me run this and then I'll show you how I implemented it because it's a little different from what you're thinking of. Okay, so the way that I have this implemented here, actually the code's going to be a mess. It's easier to just show you on the algorithm. So the way that they do this for like their full method, they do lclip. This is the PPO policy objective. And then this is the value loss objective, right? And then every so often, not very often, they distill the value function into the policy, right? My lab's interested in starting large deep RL projects and also in process building cluster. Wondering if you had any recommendations on GPUs. Yep, just our exact blog post here. I don't get Intel chips though, is the only thing. We've had so many freaking problems. Puffer stack in the blog. You just buy desktop boxes. You don't care as much about VRAM. You do care about having good cores. So the latest builds we have are 9950X, highest end AMD chip, and then these are 4090s. We're buying 5090s now. That's what we're doing. Yeah. So Ryan, so that's what they do. So what I was going to do instead is this part, we just do however many epochs of PPO. So this is just PPO. And then every like 32 epochs of PPO, because that's what the frequency they do this with is, right? So every 32 epochs of PPO, you just do an additional few epochs of value function training while using the policy cloning objective so that the base policy doesn't change. Does that make sense? I don't think we can get 40, 90, 50 due to NVIDIA policy on incorporating them. Well, that's the thing. You don't build them into cluster machines. You just buy individual desktops. If you're gonna buy H100s for RL, you're just burning money. Like if you're doing like standard deep RL stuff and you're buying H100s, you're just throwing away 90% of your budget because they're not any faster and they just cost 10x more. You don't do separate value policy epochs yet. We do right here, right? This is the separate. This is training the value function while using the distillation loss. How much are these? Are these things 7 grand? I don't know if this is remotely accurate, but all the data center cards are like, for RL, you're just lighting money on fire. Like if you're gonna buy those cards, don't buy your own hardware. There's no point. Just rent it. If you're gonna like, if you want to do your own cluster, like do so. Like this is the way that you actually do it cost effective, because this is like 50 grand worth of hardware that pays for itself in 3 months. Man, I'm not really seeing this. It doesn't hurt, but it doesn't really help anything so far either. To breakout. The value loss on these is also just really low. You know what we can do? We can look at sounds pretty similar to the original. Stop grad may matter. We don't want to do the stop grad because then it's no longer compatible with PPO. You don't think CPU course, even for GPU, not for stuff like CraftX, but here's the thing, there aren't that many EMPs like that, and like, we're collabing with that lab. If you, like, CraftX is not a good way to write an environment. Like, the guys that wrote that are incredibly talented, and I couldn't have written it that way, but like, I could make that EMP 10 times faster with less than half of the effort if you just write it in C. There's literally no point whatsoever to writing environments like that on the GPU. My advisor wants to be able to do large model fine-tuning. Well, that's no longer RL. Like, that's now a different class of problem, right? That's the only difference for the first part. Yeah, Ryan, hang on. Let me get rid of some of these runs. So why don't we just do new baselines? Let's just do new baseline so that we're absolutely sure that we're correct here. Yeah, my suggestion would be if you want to do RL, but like the lab's also messing with big models sometimes, would be get a few desktops for RL, and then do if you need H100s or something, just rent those. Don't set up your own H100s. There's no point. The arbitrage is on like desktop class machines. It's not on the server grade hardware. Those are actually really cheap for what they are. The CPU cores, by the way, are basically so that if you need to run slower RLMs, you at least kind of can. If you don't have those and you want to do anything outside of the really fast M's, you just can't. You're just screwed. There's no way around it. You just like straight up lose. So like stuff like the Pokemon project that we did wouldn't be possible on like we could rent $100,000 server and it would be a third of the speed of one of our $5,000 boxes. Like we've timed that. It's kind of weird that they do like this is really not that much extra value function training, right? I guess we could crank up EOX. Yeah, it looks like it still keeps going up. So we might just crank that. This does better at first and then worse after. It's really not that much extra value function training, right? What if we like crank this up to like 32? What happens? The value loss should really drop, right? But do you see why I'm doing it this way, Ryan? Like, the idea is that you just keep PPO and then just do some extra value function training if you want to crank up compute. Because they say that it actually, like, if you just crank up PPO epochs above 3, you literally do worse most of the time. Well, their base algorithm doesn't work by default because if you just change the x-axis to wall clock time, they're slower. So I could have just done, more samples. So we're absolutely not doing that. And like the separate value function as well is not like just 2x memory or whatever. It's half the speed. It's like 1/2 speed. So that doesn't seem particularly smart to me either. 9950X Relo. Don't get AMD chips. I mean, Intel. Don't get Intel chips. Intel screwed us so badly. Yeah, so this is like a $700 processor that will just shred everything. Now, if you have really, really CPU intensive environments, and you really want to build like a machine that can handle that, then you consider Threadrippers, but those are way pricier, and the individual cores are usually slower. Is it actually worse on time efficiency? Is it not similar? Well, if you have two separate networks, you double the forward pass cost, right? Which then doubles the train time as well. Okay, now we do see this thing as being slightly lower for most of it, right? The spike is weird. Plus sample efficiency but speed. You don't do plus sample efficiency but speed because, like, you don't want that as your base case. Because if you have unlimited data, you're just always happier chewing through more data, right? So you screw yourself on a big class of problems if you do it that way. Let me try. What do you mean no? Here, so like if you make training take twice as long, what's wrong with Intel CPU? They shipped 2 consecutive generations of broken chips. No, my bad. It was one. Was it 1 or 2? I think it was 2. Either way, at least 1 generation of chips that just break after a few months. So we literally had like, it cost me like tens and tens of hours of maintenance and like, tons of cluster downtime dealing with it. And also you have to have specific infra as well because some of the cores are fast and some are slow. It's a pain in the ass. Just get the AMD chips. I'd always prefer a method that runs at the same speed but fewer. It's not the same speed though, because when you have 2 separate networks, right? In PPO, if you have a shared value function, like it's basically no extra compute for the value head, right? If you have 2 separate networks, the torso is unshared. It's double the forward pass time, and then you end up with double the backward time as well in training. So you just take a flat 2x cut to everything, right? So if your sample efficiency, like if you have a fast env, it doesn't matter because you're still running at half the speed. So you're getting half the data that PPO would get in the same time. So it literally has to be double the sample efficiency for having unshared value function for that to work. And just unsharing definitely doesn't do that. Like maybe with the whole rest of PPG it does, but unclear. Unclear. It is more sample efficient. It takes longer. Longer per sample. I mean, there's only so much sample efficiency you can get though, right? Like, some problems just need fresh data. Like, you need to see the new stuff in the env to learn it, right? Okay, so this actually spiked the value loss up a ton. Well, that's the thing. It's problem dependent, right? And it's problem dependent, but you don't you change the base case. You kind of want to keep PPO as the base to learn ProcGen games. I mean, how much do we trust that result, right? They didn't control for wall clock at all. Okay, so this run is better. Question mark. If we do this is like the most we could possibly do. Have to run experiments, yeah. I'm trying to get a feel for if this does anything at all. And just pull the clean RL script and run one. Well, like, does that even tell you? Because, like, the bottlenecks in the clean RL are completely different from the bottlenecks in an optimized RL setup. This is like really slow, right? This is why no one looks at time efficiency. Well, but that's like stupid academia shit, right? Because that's ultimately what, like, the only thing that matters. Like, even for any fixed env, you want it to train faster in wall clock, right? So if you have a slow env, it's not like, oh, we care about sampling. No, you still care about wall clock. It's just that the env is more of a bottleneck, right? So if you like take a slow env and then make your method run even slower, you're just dumb, right? Like, ideally, you should be consuming samples at the rate that you can produce them. Yeah, so this totally just crashes stuff if you do it too often, which is in line with the result. So I would agree with you if the field has not been like taken this to utterly stupid extremes repeatedly. This learning 200x faster is also known as how do we spend 2 weeks per Atari environment. 200x faster, like, this is literally how do we spend 2 weeks per Atari env. It's insane. And like, if you actually look at the methods in this, like, they're just doing insane shit that's just like, how do we burn as much compute as physically possible? So this is like the give a mouse a muffin thing. It's like we've given the mouse one too many muffins. Academia has taken it as license to just do stupid shit instead of making real progress. And yeah, we're not taking that anymore. Yeah, I haven't seen this do anything useful at the moment. Um, do we even get like value loss? We really don't even see anything substantial on the value loss. Let me make sure I'm doing it right. Every sample, we train a full agent with and without that sample. I mean, they are literally doing stuff like training populations of agents to see which one does better. Yeah. It's kind of batshit. This thing doesn't seem to actually reduce value loss. Is that likely a bug? I don't know how it would be a bug. I mean, it is actually lower than this for a lot of it, right? It's a stochastic policy. There's like only so much certainty you can have. Like the value loss can't ever go to zero with a stochastic policy, right? Could. Well, like you don't know if you're actually going to get hit the ball or just wobble, right? Like halfway through training, the paddle wobbles a bunch, so we'll just randomly miss stuff. You can't predict that. It's weird it's not decreasing in my... Yeah, that is fair. We have it right here, though, right? All right, we'll do a couple more things before I say this isn't worth time. I don't necessarily really like. I'm not in love with this method or anything, though. So now this is no policy gradient loss, just extra value loss. Value loss consistently decreased. That doesn't make sense to me. Value loss should increase over training. It should be end dependent though. Breakout changes a lot. I mean, most M's should. I mean, breakout is like the fundamentally looks the same regardless end, right? If anything, like a lot of M should be way more volatile than that. I mean, this was going well until it collapsed. We could go back to like 6 epochs or whatever. Maybe this is a more reasonable thing to do. Top block. It does change when you break the top block, yeah. Is there a state-based version of ProcGen? Like, those M's are actually fast. Technically, we could just, like, we could probably do a version of ProcGen that doesn't render and gives you state-based obs. Because, like, ProcGen M's themselves are solid C++. Like, we could probably grab them and no emulator, right? Like, we could probably just grab those and, like, have a bunch of new M's to play with. Yeah, the obs are always pixels, right? But, like, they have code somewhere that renders stuff. Like, they're just individual C++ files, right? They don't render every framer. Well, instead of rendering every, like, can we just get some buffer of obs out that's not frames? Here's coin run. Oh, it definitely would. And it's annoyingly, it is C++. But, like, I think they're all block assets even, aren't they? Big fish. Can ChatGPT not? I generally assume ChatGPT can't do anything. Maybe. Babysitting ChatGPT is just not my idea of a fun time. Neither is translating C code. I mean, but like the thing with those two, it's annoying because you actually have to think a little bit about how to replace data structures, right, that don't exist. I'm stuck in. What are you doing with CUDA? Since when do you write CUDA? Oh, installing it, not writing it. I mean, these are like reasonable. They all have like block-based assets and then entities that can be discrete or continuous. I mean, I wouldn't be so mad about using this as our image-based, like image-based benchmark either, because we technically probably could. Like if we do anything with image-based stuff, it would be this. The VN's where it works. This is what you get for using VMs. You're lacking the puffer infra experience, man. No VM Docker. Just raw install on a Docker so it's perfectly replicable. Not using Docker? Yeah, that's your problem, right? That's why you're suffering. Don't suffer, use puffer. So I haven't been able to get this version of this algorithm to do anything. Why would you even need to convert to C? Just bind the existing. Yeah, we probably could, Captain. I don't know how their whole render setup works. I'm trying to think if there's anything I could possibly be missing with PPG. I guess there's one other thing. What's this? Oh yeah, that's the old version. That doesn't matter. So let's just do the original here. Okay, and then we'll do up here, the V loss will get zeroed. You can't copy VMs around like that, Ryan. You mess up symlinks as well. Okay, so this doesn't work. Well, to be fair, you have a computer with 7 different environments. In all fairness. It's worked so far, doesn't work now. Just because it's something that it's designed for doesn't mean it's not shit. Try this. Yeah, so this doesn't work at all without the cloning loss, right? Because it just diverges. Like it starts learning and then it'll diverge. So cloning loss is a thing that makes it work, but it doesn't seem like it's clearly doing anything. Okay, one last idea. We do this thing normally, and then we do this loss, where is it? The whole loss here. But we set this to like, was it 6? 2? Set this to 6. Every 16. What are you working on? I am currently, give me 1 second here. I'm currently working on variations of phasic policy gradients to see if they do anything for PufferLib. I'm trying to like see if I can use some of the techniques from this paper in a way that doesn't slow down learning so much. Okay, so here's the idea, right? What if they didn't have their value function coefficient trained when they wrote this paper? So what if it were something like this, right? Does that change it? Would that make sense actually, Ryan? What if they just had a shittily tuned value function coefficient, right? So their value function wasn't getting trained enough. Okay, so this is PPG with shitty value function coefficient. And then we do it without PPG. What was their value coefficient? I feel like you need to make sure your implementation replicates their results before testing stuff, though. It depends how conclusive we're being, right? Because I don't actually want their version. Like, I don't actually want their algorithm. I want some, like, adjacent things from their algorithm. So the aux phase code is literally just copy paste the whole training loop and change the losses. I mean, kind of, right? Look at this. That's a bigger gap than we've seen anywhere else, right? They regenerate policy logics. No, I do regenerate policy logics. I implemented that today. So first of all, I didn't screw up that badly, Ryan. So this is the main loop, all the freaking code, yada yada. And then here's where I regenerate logics and values for baselining. And then we use those here in the KL loss and the value loss. So there you go. So what you're looking at with this, right, is I took the value coefficient down to 0.5. So value coefficient at 0.5, now PPG is better than PPO because you would do the additional value training. So PPG is pretty close to the original tuned PPO, and the PPO with the lower coefficient isn't. I mean, we could technically exacerbate this as well because they have a worse optimizer than we do, right? So I think it's here. So they have a worse optimizer as well. So I could go down to like 0.25 and we can see what that does. Let me see what coefficient they used. They don't have one in here. I guess CleanRL would have it. Oh, 0.5. With a worse optimizer. I mean, eh? And then we do 6 epochs of PPG, right? I don't think they changed any hypers. Well, yeah, so what that means, right, is you could find, like, you found an algorithm, like, you tuned an algorithm to the current hypers, is a possibility, right? Wouldn't be the first time in RL. I mean, that looks pretty. Yeah, so this is the only way we've gotten PPG to do consistently better, right? This would be consistent with undertrained value function. Arguably, this end is also very easy. So, this effect could be magnified a ton in harder M's, right? Let me see if I can get like one other M to run. MOBA or something. Welcome. Are we doing PPO breakout? We were, yeah. I think the M is a little too simple. So basically what I'm trying to figure out now is where the perf improvement from phasic policy gradients is coming from. And I'm suspecting that you can do similarly well just by increasing the value function coefficient. Shoot, this isn't going to run, is it? Yeah, we've got some screwy things happening with some of these M's. We could do snake, maybe. Enduro. Let me see which of these we can get to, like, run quickly. Yeah, these haven't been ported up to the new code yet, right? I mean, we can do snake. Let's at least see if we can replicate this on snake. Is it hard to set up bindings for procgen? No, we can train procgen, it's just really freaking slow. Like, procgen is 300 times slower than this with their base network that they use. After optimizing. I mean, I could just run it on, like, actual breakout if we're doing that, right? What do you mean by the coefficient of the value function? So when you train the value loss, you usually apply a coefficient to it. You usually like multiply it by some coefficient, some fixed value as a hyperparam. So their default is like 0.5 and ours is usually like 2. So it's quite possible that they just undertune the value function. Okay, we'll do a pixel env because apparently pixel envs are cool or something. If I can get this to run reasonably quickly, at least. I'm trying to think about this and like actually does this work? Kind of. It's going to be rough with the new vectorization, I think. Let's just do. I haven't done anything on Atari in a long time. This is why I didn't want to do this, because I just know that the current dev state is like we need to like update everything to the latest binding signature, right? still just not going to be able to, like, there's just like a ton of work I have to do on this in order to update everything to the new signatures. Let me go back to doing this on Snake at the very least. Three runs real quick. First run, normal baseline. Make sure I haven't broken anything doing all this bullshit. I've definitely broken something doing all this bullshit. Okay. There. Reasonable baseline. So this is one window. Remember this. Second window. Baseline. Honestly, we don't even need this for more than 40 mil. Baseline with shitty clipping coefficient or shitty value function coefficient. LOL does better. To be fair, we didn't tune value function coefficient for this sound. We tuned it for breakout. Okay. Unplanned. So now we'll just do some PPG epochs with and without shitty value function coefficient or whatever. Just like, do we get any signs of life whatsoever from this thing? Okay, underperforms this one. What about with this? Okay, that's something. Barely something, but oh, you know what? Dude, how did I let myself get nerd sniped by this? You know why this thing probably doesn't work? This is not any better, right? Yeah, it's on par with original. So here's the thing I always forget about, right? I don't know why like, this happens every bloody time, and I always forget about this. So, like, this is how you fudge all research, by the way. So, unintentionally as well, I should say. So, you see all these hyperparams? Yeah, they just take these from the original repo, right? So these are just from the original repository. They don't retune them for this work at all. And then they go introduce 6 new hyperparameters with this new algorithm that they do tune. So like when you introduce 6 new hyperparameters and that you are actually tuning them, you can basically come up with any old stupid method and it'll work. Now, to be fair to them, I think that the results they have here, like they've actually got pretty clean graphs on a lot of these things, showing that yeah, there's probably something here. But I'd be very surprised if the gap is as big as this in general. Like once you actually have correctly tuned hypers. I don't think you can just add hypers and get good results across ProcGen. Happens quite often. I mean, the idea there is like you're adding extra tunable knobs, right? So like here, let me give you a really dumb example, right? Let's say that I just add another parameter in front of gamma and lambda, right? That I call like my super awesome gamma and lambda. And then I don't tune the originals, but I do tune my parameters. Boom, I set soda, right? And actually, ProcGen was solved just by tuning PPO hyperparams per env. That assumes the original hyperparameters aren't tuned. Believe me, they're not. They're shit. ProcGen was solved just by hyperparameter tuning by MBU. Prem isn't the same problem? Well, the original problem's stupid though, because like JE fundamentally means that you can't have optimal params. And also the originals aren't tuned. Look at them. They're like 0.5 and like 0.95. They're just the ones that they grabbed from Atari or whatever, right? I guess they do like the long horizon version of 999. Yeah, like these aren't even like second digit. Yeah, these aren't tuned at all. This is just Atari default. Atari default. Like these are all just generalization is a dumb problem. Well, it is in this case because like you can't solve it with PPO because of JE. right? It is actually, literally is a dumb problem trying to solve when you're using GAE with a fixed coefficient. Because GAE says this is the time horizon I care about, and then you give it time horizons with different problems. Like the smart thing to do is to try to replace GAE with something that doesn't have that limitation. But just like, oh, we're going to use GAE as a core component and then try to do it anyways is really stupid, yeah. I mean, that's literally why this benchmark, this benchmark was unsolved for a long, long time, right? And then literally you take the dumbest baseline, you just tune the params per nth, and you full solve it. That's not like, and that's like despite the best efforts of people doing all sorts of fancy algorithms, right? That's not like, oh, different problem. That's just the original problem spec was dumb. And it highlights like something dumb about PPO, right? I don't know. I'd be interested to see like if you just tune gamma and lambda per nth, right? That would be interesting. Not possible. It's possible to do. Yeah, it is, but like you full solve it just with default PPO, right? It's not hard. I agree. We should spend more time on GAE replacements. This is why I was like banging my head on P30 for a while, right? And I'm still gonna go back to that. I would be interested to see how well you could do if you tuned one set of hypers across all the m's, right? But you tune per nth gamma lambda. I think you do pretty well because since I added muon, pretty much the only params I really have to tune very often when I have like comparable model and stuff are gamma, like just gamma lambda. Everything else is kind of fine. The thing is, we've actually kind of done that in Puffer, right? Because like we solved all the m's out of the box in Puffer with muon with pretty much same hypers. I think we changed like batch size for a couple of them because some are faster than others. But then like there were a couple m's where we had to reduce lambda to solve. So like there you kind of go right there. And then I looked at the Procton hyperparam sweep results, and I can tell you it's the exact same problem looking at those because they have like lambda or they have like gamma equal 0.7 in some of them as optimal. So actually, there you go. I can tell you the result of that right now is that you do pretty darn well. I mean, this definitely is tuning value function coefficient, right? Spending extra epochs on value function. This means that you've basically tuned cross n value function coefficient when it wasn't tuned before. These results at the top are interesting, right? This is E aux, and this is E pi. Would help so much. I don't think that they help so much. I think that you actually like close this gap by at least half is most likely if you just tune. I wouldn't expect most of this. Yeah, no, I think the directionality of the result is interesting, right? But I think that the magnitude is likely very overstated. Actually, let me see. So they didn't report this, right? They didn't report EV, did they? See, yeah, they don't actually have EV on here. Isn't that funny? Oh, they set this to 1. So they don't actually even tune the value. Like, they don't even do this more, right? Let me see if that changes anything. Well, this one here, they actually do extra steps. They had an ablation on this, though, right? Let me find it. I swear they had an ablation on this. Okay, so they lose some of the perf if they do 3 value updates. And then they remove L value in aux phase. Interesting. But this is also with the unshared one, right? This is with the unshared net as well. I think that this perf degradation would probably stack really badly with this. Oh, also this is fucked, right? This baseline is screwed. Look at this. Separate network PPO. Man, that makes me like not want to trust this at all with it like this. There's no way, right? There's like actually no way you get this big of a gap, right? Yeah, it does outperform shared network, but my point here is like there's no way that like doing separate networks, which is literally more parameters, does like crazy worse. And in fact, like often people use separate networks because it does better. So I think that this whole gap is hyperparams. Heck, I think if you tuned it correctly, this should be above this one, right? You have double capacity. The heck is a value feature? Does it make sense that that's actually a thing? I guess the whole paper really hinges on this, right? Like, if not for this graph, I wouldn't even pay attention to this paper. Value prediction has to be harder than learning the policy, it says, right? Because otherwise, why would it benefit from more epochs? And value function usually lags as well, right? Mm. I'm trying to think here, like, they probably do have something here. My best guess here is that they do have something, but the magnitude is way lower than stated. Because, like, would we care about this paper, right? Let's say, like, how much do you think you get off of just tuning the hypers better, right? Like, if this gap were closed by half, would we really care that much about this? I mean, if you wanna do that, yeah, that would be awesome. Um, but I don't like. I think it needs a better tuned baseline, right? Because I really think that there is. I think this is a weak baseline problem. Like these graphs are cool because like the fact that your policy does worse when you reuse it and the value function does better. Some exact experiments you want to see. Well, the most expensive thing is going to be would be the hyperparameter tuning, right? I guess one thing would be to see whether the way I'm implementing it is just screwing it up. So I think what you would do then is you would do full PPO. If you just do full PPO, like one epoch full PPO, right? And then I think this is 16 or 32 epochs, you do the extra value stuff with the distillation. So basically remove the stop grad. I think if you just remove the stop grad, that kind of does it, right? I don't know if it's how it's implemented in the CleanRL repo, but I also would like to do these at the same time. So do these, like, these should be done jointly, right? Well, because ePi and EV can be different. So I would do these jointly with the shared network. So do the shared network variant with these steps done jointly. CleanRL doesn't implement that? Perfect. So in that case, you can just do one epoch. You can remove the stop grad, and you can see if that screws it up. And then what I'll do is I'll save this stuff here. I'll like add all this stuff. Don't need that. Yeah. Well, ironically, I think that if the stop grad thing doesn't work, Well, I'm trying to think of what is the case in which it is worth it. Because if removing the stop grad doesn't break the method, right? Then the fact that it doesn't work in my code is like, okay, maybe the thing just doesn't work. And if removing the stop grad does break it, then it's like not super useful because it doesn't match PPO dynamics. Though I guess technically we could do. Actually, here, if stop grad does break it, then yeah, there's a way that I can slot it in as like an extended compute option. So what we'd want, like what we'd see is if this method is actually good, then you would expect removing stop grad to break it. Yeah. So that would be the thing that we would be looking to see. Let me use the restroom real quick and then I'll think about what's next. All right. Let me send one quick text and then we will work on the next thing. All right. So I think that we just figure out, we start figuring out some merge stuff. There are kind of two parts to this. There's the new binding. Let me see what's Bet has PR'd. Because there's two things that we need to do. There's the new binding stuff, and then there's some pretty serious vectorization stuff. Okay, so like Bet has this here. The main thing right now, I guess, is like, I'd like to just merge this into dev and then fix all the binding crap. But the vectorization stuff is going to be an issue. Okay, let me think about what we can do about this. So the problem is that the new buffer stores segments, so it doesn't like it when you get variable length segments. Shouldn't my thing actually work with that? I think this actually should work. So I actually think that there shouldn't really be any issue running any of the M's. So maybe actually it is worth it to see why Atari is hanging right now. That might let me merge it. Need to go back to my work. See you, Ryan. Get the thing done. You gotta just finish writing and submitting that thing called a day. Or whatever you're doing for finishing degree. Trying to do actual research again. Yeah, that's good. See ya. Where's this hanging? Is this hang on receive? I see it. Yeah, I see it. Okay, well, I know what the issue is now. Yeah, that's also a multi-discrete issue, right? You don't really... Do you need batch logics for anything right now? Not really. Okay, so this runs. I think this just takes a while to log, right? Yeah, there we go. Let's see if this trains as is. There we go. It's learning. $50 mil. Okay, so this still trains. That is good. Commit this up. Okay, so I think we will actually be able to do the big merge relatively soon then. I don't want to start it right now because I'm going to dinner in a bit. I'm also a little tired. I don't want to like screw this thing up. I do have a few other things to do. Check one thing. There was one other thing I had to do today. Okay, so I think I actually then, I think what I do, we go here. I have to figure out how to run this. That's funny. Let me go find the thing. Oh, why did it get switched to camera? That's weird. Let me go grab all the stuff I need for this. The other thing I had to do today was just checking on some of this here's the animation gen work we did. There's some reported issues with it. going on here? Does this freeze? I actually thought that this one worked before. Maybe it's... Oh, maybe it's this. There we go. So it was just too many damn motions. This is probably running 4096Ms or something. See if I missed anything. No? Should be fine. should be finished, right? Is it actually even running anything? It is, just very inefficiently, right? Yeah, it's not even using any CPU. I think it's just stuck. Weird. It's like it should have spit out the results, but it didn't. -- final eval. Ah, space. Let me figure out what the heck is wrong. This is like shared storage or some bullshit, right? What the heck is it even trying to write to /temp? Oh, this is shitty internal, like, stupid internal torch multiprocessing. Yeah. Now I remember this being an issue. Hang on. Seems like there's space here. Torch elastic. I'm trying to think what I can do to get this stupid thing to run. I have space. There shouldn't be a cap on the Docker size, right? That does anything. Or if it just OOMs. We'll see. That might be it, right? I think I might be able to just like start the container separately. One sec. Okay. We can actually just do it with start. Hang on. Yeah, this will work. We can literally just do this, apparently. I'm hoping that I don't have to remake the container. I think we can just reboot it and then we can actually get some cool evals. Unknown flagged. Yeah, so this doesn't freaking exist. Good job, Grok. I don't want to remove the damn container. We'll just make a separate container to test this, I think, real quick. That's what we'll do. There we go. Now we reset up this repo. And hopefully I have all the data. Okay, that'll install that, and then we should be able to test this. And hopefully that fixes shared memory bullshit. We will hope. So this right here, what we're waiting on, this is why you don't use virtual M's. If this were just part of the Docker, we would be done instantly. Instead, you sit here waiting for 5-10 minutes, whatever, every single time you want to like remake a dev environment for whatever reason. Okay. We get our shell. Hey, Bet, we're just testing some animation stuff for a bit. Um, I tried some stuff with phasic policy gradients. It didn't really do much. We might want to come back to it when we have like a stable version of dev, so I have access to all the envs for testing correctly. But initially it doesn't do much. Yep. He's gonna go run some experiments as well. Yeah, it's this Kyung's thing. Some folks are having trouble with it, so I'm just like seeing what I can repro. We also need the model. See if this still OOMs. If this still OOMs, we might just have to screw with something. I don't know. There's like PyTorch multiprocessing kind of sucks, and there's like some weird shared memory resource out of memory thing. It's not like it's not actual RAM, and there's some like weird shared resource thing. Yeah, so this seems like it's still stuck. Oh, there we go. No, that actually works now. Perfect. So that did fix it. Tyler, why are you writing fanfic in the stream chat now? What are you doing? No, that's Tyler. Tyler's not an LLM. Unless he's just pasting random crap in now. Tyler actually does cool physics shit. What the hell, dumb? What the hell article is this? We're not reading stupid White House articles on stream. Success rate 0. Oh, but this is, yeah, this is only on this one motion. This is just dash M. Less bureaucracy is good, yes. No AI regulation, please. Leave us alone and let us build stuff. Yeah, all the code in this is just all so slow. There's only so much we can do on this stuff, right? It's like, robotics just has too many years worth of accumulated god-awful software. It's the type of thing where I'd like have to really focus on it for quite a while to like fix everything. There's like a very large amount of stuff that you just would have to completely scrap and rewrite. Okay, that does look bad. Hey, bud, you live today too? Yeah, I was working on phasic policy gradients a bit earlier, and we're just checking on some code we shipped recently. I think there's just some dumb model load mismatch or something. Oh, well here, look, it's now we are getting success, right? This actually should be done pretty soon then if this is how it's doing it, because yeah, there's only 11K of them. Okay, we'll let it finish, assuming that's what it's gonna do. Hello, YouTube folks. I mean, for reference, what this stuff is here, this is animation gen RL stuff, so it takes motion data, like captured or like generated even motion data that may be messy, and then it runs it through a robotic sim, runs it through Isaac Gym, and I mean, when you're running it in a sim, like your foot can't go through the ground and you can't do things that don't work with physics, right? So then you do RL on that sim to actually make the thing match the original motion within the bounds of physics, and then you get better generated animation data out of that. The only problem is that this whole area has like total mess of software. So like I did a little bit on cleaning stuff up here. Kyung did a lot on cleaning stuff up here, and we got it way better than than when we started. But there's still quite a lot that's just tough. Okay, so here we reproduce the batch success rate 987. Oh, Kyung's around. Perfect. Hey, Kyung. So I reproduced the batch success rate. Is there a way we can just like get random batches of motions without taking forever and just like see them play so we can see if they're working? That would be ideal. Streaming looks like 1 minute delayed. It shouldn't be. Hang on. Where away sample batch motions and see on this whole file. Maybe this just works. Oh gosh. Thing takes forever to load. Oh, here it is. You kind of can't. You can't move the camera, right? Press left, right. Oh, thank you, Kyung. Play shows you 16 M's. So yeah, the sitting down one is like, oh, it actually even does that sometimes. That's crazy. Yeah, these look very good. These look very good. It looks to me like it works as is. I'm trying to figure out what the heck they did. Now they sent me a repo invite that I can't show on stream. Like they didn't give me good information about like what it was that like how it was that they were trying to do stuff. Cause like yeah, when we run your stuff, it works as is. The only thing that was rough, which is why I had to why I started bothering you about this, is I couldn't get it to run initially. I had to modify the Docker container to have more memory, or it would just crash. So I was like, okay, there's something screwy. And then when you only run like the first eval step or whatever, it shows 0 success rate. I don't know why, but then when you run the full data set, it shows way higher. To be clear, this is not picking success motions out, right? This is just random motions. Like, there's occasionally NAMs, I guess, once in a while, right? But looks fine. Yeah, that's okay. Yeah, that's the thing Linky fixed, right? I gotta integrate all that stuff in. I mean, that's pretty impressive, right? That's like hard to do. Most of them, yeah, it's like 98 or something percent. Let me see if I can pull up this repo on in a separate tab and just see if there's anything. Just go over here. They're probably like doing something screwy with the loading. Where do invites go? Let's see if I've gotten invites. Okay. Oh, is this... Hang on, this is... Let me see if this is open source. If it's open source, I can show it. It says, it looks like they're intending to make it open source, but, like, they've got stuff in there, like, that would imply that, but, yeah, okay. I think that they're going to release the thing with their modifications soon. How would you upload these movements to an actual robot? So this is SMPL. You would have to do the same thing on, like, you would have to retarget the motions to a robot, like to the actual rig for the remote robot itself, and then address like any weird sim to real stuff. Let's see if there is anything I can show. What's up with the nans? Presumably just diverging trajectories. Like, the loss is going to be a squared error, so as soon as the thing falls over, it just goes crazy. Yeah, I'm doing RL pretty much 24/7 these days. Okay, well, I don't think that there's too much I can do on the thing for them now. I kind of just gotta chat with them at some point because, like, it looks like the code for this is fine, right? We get all the motions look good. Um, yeah, I don't see any issues. I mean, I would presume it's gotta be like loading screw ups, right? Like they have their own data formats and they're doing a whole bunch of data conversions. There are like a ton of places that you can get stuff wrong there. And like, yeah, of course we'll help, but I think that the thing that we delivered matches what we were supposed to deliver here. I don't I don't see anywhere where like, oh, actually the model's screwy or anything weird like that. So I'm not too concerned there. So as long as it's that's taken care of, I'm happy at least. And then you know, if they need extra help, I can deal with that as separately. So I guess we can go back to the merge stuff. There really isn't any impediment now to merging, right? It's 4:38. The only thing is like I have an hour before I've got to run for dinner. It's not a terrible thing. Like the dev branch is broken anyways, right? It's not bad if I just do the merge and then start working on it and get as far as I can. I don't see any reason not to just do that. Yeah, let's just do that. Okay, let me get my my original Docker back. So now we'll actually get to some interesting dev where I can actually show stuff. I just wanted to make sure that the thing that we delivered was what we said it was, and it is. Just a sec. Well, we can just do merge. So I'm gonna have to immediately fix a ton of stuff with this. Not too well, that would be terrible. So we do this first. Big merge. Okay, so this is no big deal. I'm gonna have to get Kyung some robots so like he can actually do robotics. I wonder if I get him some some robots that he can remotely control. Maybe then I can get him to keep doing puffer dev stuff. Uh, just like get him a whole ass unit tree or something that he can just like walk around the puffer facility. You can train the robot to like do cluster maintenance or whatever. Or try to. Oops. Put a cam on it in the corner of your stream. Actually, the new stream is going to have a full view of the facility. It's going to be really cool. Have all the servers in the background. It's nicely set up for that. Feels good to be back on the dev branch. You have the oversized American flag yet? We have one. I don't know if it's big enough. I think it's like a 15-foot flag. I wanted to get like a 25-foot flag. Okay, so yeah, with the bindings, there's like one annoying thing. I don't know why, I guess because this is only a prototype, I thought you would still be able to export it. That's weird. Yeah, this was supposed to be optional. Like, I can just comment this for now, and it'll work. This is for grid mostly. No, but we're not going to do it in a way that it'll conflict with each env, man. Like, we're going to find a better way to do it. Why is that not? There we go. I'll rebuild all of it. Is there a way to make it? Yeah, well, we'll figure it out, right? Dash force. That's good to know. Okay, something seems sketchy there, but so what's happened here? Yes, right, merger changes. All right, so we do your PR. Next. This one, right? Did you break Snake in one of the recent ones? Okay, you didn't PR it. Good. Yeah, Snake's kind of important. Like, we use that one pretty often for testing. Affront to the puffer. The puffer is quite sizable. The puffer is indeed quite sizable. Now we get to see how well my new stuff works, right? Presumably this is building kernels or something. Yeah. Okay, so we can track this. It's the pop-up. These guys messaged me at all? They were supposed to tell me when they were free to meet. And they just straight up didn't message me. By 5, yeah, it's fine. Oh, also, this is the latest Neural MMO3 run with the new stuff. It's kind of cool. So you can see right here, so this is the old one versus the new one, I guess. So you can see with the new advantage estimation, it's like a very small but consistent upgrade. It's like very small but consistent. It's like across the whole curve, it's just very slightly above. Possibly a little more stable as well. I believe this black one is... Does something have a name on it? I believe that this one was just like bigger filters that I forgot to like add back in. Yeah. We'll get to that, no worries. I mean, still, this is good soda. So, this is our latest one, probably. It's not bad. Yeah, good curve. 864 is max, but yeah, it's good. That's like basically full solve. That's like it dropped a point once or whatever. I don't know, man. Nobody knows how to write software anymore. Okay, palm trains. And then jumps to full solve. 21's full solve. Good. Okay, so snake is not training correctly, but I saw this in my branch before. There's like an inconsistency, I think. Yeah, there's some like weird inconsistency when you use multiprocessing with this. Like that took it way longer. To be fair, it's not bad actually. That just like the curve is shallower early, but that's where it should end up. This is fine, right? All the way 500. It is going to dip a little bit. That's normal though. It shouldn't fully crash, but it'll dip into 70s sometimes. It's like a competitive self-play EMF, right? So dynamics are kind of dependent on all the other agents, what they're doing. Yeah, go ahead, link your run. This branch has some slightly better stuff though than previous. Oh, we're also not using puffer advantage here. We should set this to true by default. Yeah, so that's not good, right? I think this was before I fixed, there were a few things that I fixed since then. I mean, obviously, like, you didn't get 80, and we have 80s here. This seems good to me. Let's set puff advantage true. I ran that yesterday. Yeah, you ran it on dev branch, though, not on buffer branch, right? I had to fix some bugs. So this is good. Let's try it with puffer advantage just to be sure. So I changed the default to use puffer advantage now. That goes wrong with score. Oh, there we go. Oh, that actually fixed it. The puffer advantage version actually trains way more stably. Puffer advantage for the win. Puffer advantage for the win. We eval it? Yeah. Presumably this is saved to checkpoint by now, right? These look good, right? Cool snake ends. Does this have Diane on? No, it doesn't have Diane on. Perfect. Yeah, that's just base training. So yeah, this is proper snake. I like this end a lot. It's like it was a really simple to code end, but it's really nice for testing and it looks really cool. Like really, if you just get ideas for cool projects like this, you can knock these out in a couple of days and like have them in PufferLib. So for any folks watching, if you want to contribute to PufferLib, something like this is a few hundred lines of code. And like maybe 200 lines of actual logic. And this has been like one of the most useful test ends. This was actually, I think this was the first env I wrote fully in C as well. Pretty cool. Okay, does neural MMO 3 work? That's kind of important, right? $415K. Not bad. So yeah, this is good overall as well. I think there's still a few M's that are kind of busted, but this is overall quite good. It's 5:02. If I wake myself up, I think we can do a little bit more cool dev stuff today. I don't have mental bandwidth, long, short, was it? Fast flow RNNs today. That's going to take like, I'm going to have to be fresher for that. But I think we can do some die-in experiments and see on that. So we'll do some like cool, like was it like behavior conditioned or skill conditioned policy experiments in a second. Let me use the restroom and grab a drink though. And I'll be right back. Give me like 2-3 minutes. Got a brief spiral. Want to merge Blastar. Cool, yeah. Let me do that bet. Then we'll do the experiments. First, it's weird tactical. Let me get this. Oh, also, since we're on the repo, if you haven't started the repo, what are you doing? It really helps us. Come on, guys. We're almost at 2K. This one, yeah. Okay, new binding file. That second, so don't merge this first. Okay. Puffer color is good. Cool. Presumably you're not looking for feedback considering it's a pretty clear cut what the work is, right? Yeah, and we need to figure out how to reduce boilerplate even more. But like the new binding stuff is already a pretty darn good dent in the amount of boilerplate, right? Like most of the PR was deleting boilerplate, very little of it was adding it back. Okay, thank you for PR. Next to PR. Oh, I didn't merge it, did I? Plus, I do this stuff. Oh, very nice. There's that. I wish somebody would finish tactical. That's a little too much for you at the moment, Bet, but it could be a really nice M. Yeah, so you just mess with the client a little bit, right? And this. Change to client, it's fine. Yeah, but it would take you quite a while because there's like a lot of stuff going on. I think that the thing you would get stuck on most likely would be there's actually like probably some scripted AI stuff that you'd have to do with this, which to be fair is a great thing to learn, but it's kind of tricky. Scripted AI, like doing scripted AI is honestly one of the best way to learn algorithm stuff. Like, because it's a ton of pathfinding. You occasionally do like Monte Carlo stuff. It's like search. They're like, it's actually like a really good way to learn algo stuff, but like, yeah, this would be a bit much. Like, you'd kind of just be stuck doing this for a long time. Like, that's one of the things where it actually kind of helps to have seen the algorithms done formally, right? So you're not just reading freaking Wikipedia articles. This is just a find and replace on client, right? Yeah, it totally is. Maliki text. You know, that's like where you, like your first CS course or whatever, like your first undergrad CS course or whatever usually just does that. Covers all the data structures and algorithms. And then there's like very much diminishing returns to formalized learning after that, but it's a decent base. So the 101s are kind of shit, because a lot of the first courses in CS are taught in Java or something just awful. I'm trying to think, with the scale of stuff that you've written, I'm trying to think if you know more or less CS than I did before my freshman year. Like, I'd probably spent more time writing code than you have by then. But also, like, I was doing it without any form of reasonable guidance, and I was just doing stupid shit half the time. So it's kind of actually tough to say. I'll link you the course afterwards. It's just 106X. I mean, there are like some obnoxious things, like it's taught in C++, which is kind of shitty. And like, the lecture isn't very good, to be honest. The course material is pretty good. The lecturer really isn't. But like, I don't know if anybody knows if there's a university that has a better course than this, but like they use their own shitty libraries as well, which is like, it's annoying then. But yeah, if you look at the assignments, it's like implement game of life, ADTs, Boggle, priority queue. Like these are good things to implement. But then the obnoxious thing about it is like, so you open this shit, right? This is the thing that always drove me fucking crazy with their, unless it's improved. Oh, actually this is better than it used to be. I guess like they give you this obnoxious graphics library. It isn't that bad though. So one of my big complaints when I took it was they just gave you way too much starter code for shit. So like half the assignment wasn't even implement X, it was like figure out what their garbage starter code does, which just drove me fucking nuts. But like this is stuff that you generally should see in a formal setting. Also, this course is intended to be hard, by the way. Um, Like, this is usually the thing that most Stanford freshmen end up spending 20 hours a week on, at least. Well, not really, 15 to 25 hours a week. It's a bunch of data structure stuff that's like very confusing when you see it for the first time. Okay, so everything should be merged. And we should still have a little bit of time to run a couple experiments. I want to see what version I left in here. Okay, so I want the other form of this. Yeah, I want the other form of this. So basically there are two different forms of this algorithm I was experimenting with. One of them, they both work on subsample sequences. So in one of them, you take all the observations from the trajectory segment, you downsample by a factor of 8, so you just take every 8th sample, you run it through a little model, and you try to estimate which policy this segment came from. So by what the agent was doing, like which policy is this? The other form is you do the same thing, except you use actions instead of states. So just by looking at the sequence of actions the agent took, what policy is it? The state one is much more powerful, but you have to do reinforcement learning to learn that objective. The action-based formulation is a lot weaker because you're only seeing the actions without the context of state. But it's fully differentiable, so you don't have to do RL. It's a supervised learning task, which makes it really easy. Well, actually, isn't this entire thing? Yeah, this entire thing is redundant if we're going to do the other version. Wait, what? Oh, I guess I just like removed the previous. Yeah, that's fine. We'll just do this. It's basically the same thing. State batch logits. And this isn't the spot for this loss to go. I think I made a commit with the exact version that I needed at some point recently. Where is this thing? I know I gave it a decent commit message as well. Dang, okay, well, we'll just redo it. It's not a big deal. It should just be like... something like this. Yeah, something like this. And then all we have to do is discriminator here needs to not be this. It needs to be action space shape. Action space. And then discrim forward. I think I actually was doing this on snake before. But why don't we just do it over there? Just put this model. Yeah, so there it is. You can see this was supposed to be the state-based one or whatever. That looks good to me. You just give it like a little 2-layer net. And this should have a discrim forward, right? Maybe snake. Times this. So this needs to get reshaped, I believe. Where is this getting called wrong? Right, so this is not needed here. This is the other version of it. This is 128 by 64 by 4. So this is how you do this. There was like a whole bunch of stuff I would do with this as well, actually. Yeah, was this... I think I actually just put this into a softmax, didn't I? Yeah, I think we just put this into softmax. Yeah, let's see what this gives us. Welcome, YouTube folks. We have a quite fair few people watching this at the moment. I'm here for another 15 minutes, and then I probably will be back after dinner. We'll see. But what this is at the moment, this is diversity is all you need, name of algo. It works by adding a one-hot vector to the observation space of your agent that is representing a skill. So you come up with 8 skills, for instance, and you give each agent a skill vector. And then what you try to do is you try to train a separate network that predicts which agent it is, like which skill vector it actually has, based on what the agent does. So in doing that, you try to create a policy that can behave in many different distinguishable ways. So you have one policy that can take lots of different sort of types of play. So that's what we're doing at the moment. This is actually now in the dev branch as well of PufferLib, so you can check it out there and do start the repo. It helps me a ton. Fix grid reset. Grid reset is kind of hard. Grid is the one that needs the shared stuff, but I want to at least see if I can get this to work as well, because this is going to be more entertaining. Okay, so this is 32 input dim, right? Reasonable? Mostly reasonable? Grid is the one that has the shared thing, bet. For mute. That's a weird error. Just scrim forward. Really? Oh, it probably is a one hot, right? Okay, this runs. Put it on Neptune. So the one thing with this is that the loss is usually like really, really low. The neural net is really good at figuring out which agent has which skill vector. Yeah, that goes up a little bit sometimes. So we will see what this does. There are... So here's the thing that I was trying to figure out with this algorithm, right? I pulled the paper. You need Sergey Levine. So it's this paper right here. It's a pretty cool paper. The math in here is like makes it sound way more complicated than it is. This is kind of the algorithm here. This math is like pretty redundant. The thing is that there are, if you like look at this, there are some obvious extensions of this, and like the original form is not great. So I kind of took the idea of conditioning an agent with a skill vector in order to distinguish between different behaviors. And instead of doing it on the transition level, I do it at the segment level. So you take the whole like 64-step segment or something like that, right? And you just take, you downsample it, you pass it into the discriminator, and then you determine what policy it is based on that. Now, what I would really like to do, ideally, is I'd like to have some way of defining a supervised loss that takes into account the agent actions and the agent observations, or even just the agent observations. But the thing is, like, observations are not differentiable, and there's no way that observations directly are differentiably affect the policy. So if you try to do it this way, you need to use reinforcement learning to learn which skill it belongs to which agent. And like, yeah, we do reinforcement learning all day, but ideally we don't have to add a secondary RL objective into what is already an RL problem. It's a lot cleaner and a lot easier to learn if you can just like add it as an auxiliary loss, basically, that is supervised. This is doing some weird, interesting things. It's definitely doing some weird, interesting things. How's the Dian loss? It's just been very low the whole time. I mean, it's gone back up now, right? That snake, that is my curve from yesterday. The curve that you sent me was in the 30s. There's a big difference between this curve being in the 30s and then this curve being like up around here, right? I think I will just have enough time to like get this result and then look at it a little bit. Shape is similar, but shape, that is a reasonable shape for snake oftentimes. Let me make sure the rollout is going to be there so we can look at these. Now, the problem with this, right, the problem with the action-based formulation is that the neural net can very, very accurately tell apart which agents are doing what, but we can't always. So we'd really like it to be high-level distinguishable skills, but that's very difficult to convey, right? Like, what does it mean to have high-level differentiable skills? That's pretty hard. So this will be done in 2 minutes, which will be perfect timing because we'll see this, we'll see the result, we'll see what the policy is doing, and then I will get ready to go to dinner. Went out to diner with some family. To be fair, that is like a nice stable curve. This dip is very common as well. Like I've seen this even without this algorithm before. It's just like all the agents learn how to do stuff. Oh shoot, all my opponents are kind of smart now. And then they kind of like figure stuff out. Okay, we are going to see these results, but I will do outro stuff now before results while this finishes. But we do have like 9 or 10 folks watching now. So if you're interested in all this stuff, this is all open source reinforcement learning. You can check it out on GitHub, start the repo to help me out, puffer.ai. If you want to get involved in dev, join the Discord. Most of our top contributors came in with 0 RL experience. Like, we're happy to show you the ropes, and it really doesn't take much before you can start contributing really cool stuff to this. And you can also follow me on X for more RL content. We've got a quick start guide on the blog as well as on X that I really recommend to new folks, but there's more on X as well. Okay, let's work on almost there. Let's see what this policy does. So close to 2K stars as well, like just a few more. 2K is a huge repo in RL, like I'm pretty happy with it. Thanks for the link, Bet. Okay. 92, okay, that's actually a very good score, and that was like a pretty stable. So each color should be a different skill. The model can tell these apart like perfectly, is the other funny thing about this. First of all, this is just like a very good model. But the model can tell these apart perfectly just by looking at the actions that each one of these is taking. Not even looking at their surroundings, just looking at the actions that each one of these is taking. I can't personally say for sure how each agent is different here. But also this might not be the best end for testing that, right? We could probably come up with some ends where it would be a lot more clear. Like the play style difference, maybe. They're doing, yeah, this is 90. This is 92 score, so this is very good. We will continue doing research on this, I think, over the next couple of days. Like, this is one of the things we definitely want to include in the stuff that we're looking at. So, very likely that this will be part of Puffer in some way. So, yeah, thank you, folks, for tuning in. I will probably be back after dinner. Puffer.ai for all the things. And Discord is just discord.gg.